Hey guys, we're gonna do another problem, but this problem is gonna be to find stationary points for rational problems. So, this problem is on page 637, problem number 1. So, they gave us this function, and we obviously know that it's a rational function because of this fraction. They told us to find f prime of x. That means that we have to use the power rule. But before we could find the derivative, we have to rewrite this function. So f of x equals ax squared. I keep this the same, but then I have to recognize that this x has an exponent of 1. Therefore, when I want to change it, it becomes 4x to the negative 1 minus 3. Now, this allows us to do the derivative using the power rule. When we find the derivative, the first term becomes 2ax. The second term becomes negative 4x to the negative 2, and negative 3 disappears. Now, another thing they ask us to do is a local maximum point where x equals negative 1, find the value of a. So all that means is that they want me to find the value of a when x is negative 1, and we know that it's a critical point. A critical point means that we have an x value, which is negative 1, and y equals to 0. So one key thing that we have to do to solve for a is make this side equal to 0. Equals 2a, x is now negative 1, minus 4, negative 1 to the negative 2. Now I'm going to erase the top so I have more room to do the work. So let me simplify this. 2a times negative 1 becomes negative 2a. This term right here becomes, so negative 1 to the negative 2, it just becomes 1. And therefore, this negative 4 just remains the same, and it just stays as negative 4. Now, when I do the math, I'm going to add 4 to both sides so I could find a. So plus 4 on both sides. It becomes 4 equals negative 2a. I divide both sides by negative 2, and a equals negative 2. And that is your final answer for problem number 1.